Alright, so I just found the cosine of negative 7 pi over 6, and I noted it on number 11. Yeah, let's proceed to part 3, identifying domains of the trig functions. So remember, t is a real number. Well, let t be a real number. So we're going to take sine of t or cosine of t, and when we do that, what values of t can we have? Well, any values from negative infinity to infinity. For tangent t and secant t, because they're over x, then x cannot be 0, and that happens at pi over 2 and 3 pi over 2 and any other coterminal. Those are really just odd multiples of pi over 2, so t can be anything except odd multiples of pi over 2, which we can write an odd number is 2n plus 1, and of course times pi over 2, and n is some integer. All right. Let's go on to the domain of cosine and cosecant. Right? Cosine t is x over y. Cosecant is the reciprocal of sine. So they both are over y, which means y cannot be 0, and that will happen on the x-axis, where maybe 0 and pi and 2 pi and 3 pi. So you cannot have multiples of pi. That is, it's undefined in multiples of pi. Okay, let's check to see an example of that one. So find the secant of 3 pi over 2. So 3 pi over 2 is 3 pi over 2 is down here, right? And the secant is the reciprocal of the cosine, which is 1 over x. X is 0 here. Right? This is 0, negative 1. So because x is 0, this is undefined. All right, and I'll let you do number 2. Okay. By the way, on the first page, we did the odd numbers on the examples, and you do the even. Or we will do the even ones in class. Okay. Let's continue here. Part 4: applying the period and properties of trig functions. So what does this refer to? Well, a function f is periodic if f of t plus p equals f of t for some constant p. The smallest positive value p for which f is periodic is called the period of f. And why are we talking about this? Well, this is periodic because if we keep rotating, or we keep following values of s, right, to find cosine s and sine s, s just keeps going, right, because it goes from negative infinity to infinity, right? So why is it periodic? Well, because you go through all these points over and over and over and over and over. Okay? All right. So because x and y combinations on the unit circle repeat every 2 pi, then the period of sine, cosine, secant, and cosecant is 2 pi. Yeah? That is, theta equals t is coterminal with theta equals t plus 2 pi. And that's the p that we mentioned up here. That's the period is 2 pi. Right? That means, you remember the unit circle? Right? So if we look at these points, the coordinates start repeating here. They start repeating here again, and then they repeat, they repeat, they repeat. Yeah, all the combinations are unique until you start repeating, right? Unique combination, unique of x and y, unique x and y, unique x and y combinations. But then once you get here past here, you're running into the same combinations because it's the same points on the circle, same coordinates. Okay. What about for, I didn't mention tangent and cotangent. Why is that? Well, because x over y will give you the same value as negative x over negative y. That means tangent values over here repeat over here, where you have negative, negative. And when one is negative, these values repeat over here. So they have a period of only pi. All right, let's go on to B. A function f is even if f of negative x equals f of x, and dot if f of negative x equals negative f of x. You might remember that from the previous course. Consider an angle intersecting the unit circle at a point with positive x coordinate, which means cosine t is greater than 0, right? Because it is the x coordinate, is the cosine. The value of sine t could be positive for t greater than 0 or negative. So we're looking at this situation. All right. If you think about the unit circle, cosine t positive means the x value is positive. So let's say that there's your x value takes you up to there. And then you consider the value of sine t if t is greater than 0 or t is less than 0. And again, remember the directed arc. So t greater than 0 is going to go up that way. T less than 0 is going to come this way. But let's say it's has some sine value right here, right? That's for positive t, and this on the other side, it's for negative t. Okay, so we can see then that the cosine of t and the cosine of negative t are the same value of x, right? This is cosine t sine t, this is cosine t sine t, but the cosine right here is exactly the same number, right? What differs is the y value. And the sine of negative t is negative sine of t, right? Sine of negative t, which is some negative number, is the opposite of the sine of t, okay? Because one goes up and one goes down. All right, cosine is an even function, right? Because it matches with the definition of even function, this one. And sine is an odd function, again, because it matches the definition of an odd function. Okay. In general, a trig function involving sine of t, which is y, on the unit circle, will be odd, but if it involves only cosine of t, which is only x, then it will be even. What functions involve only x? Well, cosine, and it's reciprocal. So cosine and secant. So cosine and secant are even. Sine, anything that involves y, which will be the sine, the cosecant, and the tangent and the cotangent, all those will be odd. Okay? Odd, odd, odd. All right. Let's see how we're going to use this. So, some examples. Evaluate the cosine of 5 pi over 3. Well, the cosine of 5 pi over 3 is the negative 5 pi over 3 is the same as the cosine of 5 pi over 3. So I can take advantage of that and just evaluate the cosine of 5 pi over 3. So the cosine of 5 pi over 3, remember 5 pi over 3 is going to go like this. Pi over 3 away, the cosine is 1/2. Remember the unit circle? That's what I'm looking at, right? 5 pi over 3 is over here. The cosine is 1/2. It's the same as this pi over 3 up here. All right. Were you guys able to see that? I didn't check. So I'm at negative 5 pi over 3 positive. By the way, 5 pi over 3 negative is up here, right? So they have the same cosine. All right. Let's go on to letter C, tangent of 225. So tangent of 225. That one, just find the tangent of 225. It could be the tangent of negative 135. Doesn't really matter. So where's 225? Well, it's over here. The tangent is positive 1 because this is the cosine and sine are the same. So that'll be a positive 1. All right, cotangent will be the same, by the way. All right, and then number 2, simplify, and we'll do A together. Okay, and then the other ones we'll leave for class. All right, so 2 sine t minus sine negative t. Remember, sine is odd. So I can think of 2 sine t minus sine of negative t as 2 sine t minus negative sine of t, right? Because odd means you can pull out the negative. That's one way to think about it, right? Odd, right? I pull out the negative and it becomes that. I pull out the negative, it becomes that. Pull out the negative, it becomes that, okay? So I can think of it that way. 2 sine t minus negative sine t is the same as, oops, I forgot the t. 2 sine t plus sine t, and that'll be 3 sine of t. Okay? All right. We'll leave the rest for class. And again, if you want to look them over before you get to class, I think that might be a good idea. All right, I'm going to stop here. This is the end of part 2 and the end of section 5.4.